All right, in this video, I'm going to go over number 2 from the Unit 4 free response review. So they give us a table where they're giving us actual x and y values, as well as some signs if you were to plug in a value in between those different x values. You'll notice that for a few of these, it says DNE, so we cannot evaluate the first derivative or the second derivative at x equals 2. So we'll need to make sure, and when we graph this in a moment, that we're unable to take the derivative at x equals 2. So the first part, it says for the interval 0 to 4, find all values of x at which f has a relative extremum. So that would be like your relative min or max. All right, and the way I've taught you to do this is to look at the row that is the first derivative. You know, I'm not going to highlight all of them. And look at your signs. And wherever your signs are changing from positive to negative or negative to positive of your first derivative, you would have a relative max or min for your original function. So in this case, my first one says positive then positive, so nothing changing there, but I have one here, positive to negative. So at x equals 2, we're going to have a relative extrema. And we're going from positive to negative, so you can imagine if you're in my class, or I'm using, I know you can't see me, but I'm thinking for positive, we're increasing with my hand to decreasing, right? So increasing and decreasing will be a relative max. There is a relative maximum because f of x is changing from increasing to decreasing. Or you could say the sign of the first derivative is changing from positive to negative. That would also work. All right, so that is how I'm justifying my answer for part A. Now, part B, they're asking me to sketch a graph of the original function f. Now, what I do notice is that the first row gives me actual ordered pairs. So I'm going to take a moment and just plot all those ordered pairs. So I have 0, comma, negative 1. Then I have 1, comma, 0. 2, comma, 2. 3, comma, 0. And it doesn't actually say what's happening at 4. So we'll see what happens as we go through it. Now, a couple of things I notice. All those things that I highlighted in teal will tell me where I'm, if I'm positive, that would mean where my original function is increasing, and then if I'm negative, where the original function is decreasing. And then one more thing, a couple of things I'll highlight, is these negatives and positives are going to tell me where my original function is concave up and down. So you'll notice from 0 to 2, I'm increasing, but at x equals 1, we're changing, right? See how this is changing from negative to positive? We need to have a point of inflection at x equals 1. So I'm going to try my best to show you that here. Okay, ready? So there's like a little bit of a point of inflection as I move up to x equals 2. Now, at x equals 2, we need to make it so that you can't take the derivative at x equals 2. So I'm thinking of like a sharp turn, right? Something maybe like this, right? Or a point, a corner. So that would mean something like that. And then we are decreasing all the way to the end, but we do have another point of inflection at x equals 3. So I'm going to try my best to give a little bit point of inflection. We're actually getting, we should be getting, let me do it the other way, because we're actually concave down to concave up. So more like a frown to start. So more like this. And then we're going to be more concave up as we move to the end. And again, it doesn't tell me where 4 is, so I'm just going to stop, maybe there. All right, so that's it for graphing using these characteristics, and that's actually the entire question for number 2.